Hello everyone, you're most welcome to my YouTube video. My name is Atong Abraham, a student of Makerere University, software engineer. In this video, we're going to look at changes in the climate, how we can use AI to develop a system that predicts. We're also going to look at obtained datasets, factors, Bayesian theory, naive bias. Now let's get it started. As we talk of climate change, there are some places which are having much more rainfall than the others. Others are having really exposed to more frequent droughts. And all these changes are already having big impact on our daily lives. Now, how can we really predict, or how shall we be able to know what is going to happen in 5 to 3 years coming, such that we can prepare in the future? Here we're also going to first look at obtained datasets. We use Kaggle to come up with datasets, which is climate change prediction datasets. This AI system will help us to predict how much rain the next winter might bring, or how far sea levels will rise due to warm sea temperatures. We can also see some regions which are more expected by extreme weather. It is important that we understand how the climate is changing so that we can be able to prepare in the future. Now, let's also look at factors considered when choosing dataset for the AI projects. We are having performance. The quality of modules data is a fundamental factor to take into consideration when choosing a dataset. You want to prioritize algorithms that maximize that performance. We also have explainability. In many situations, explaining the results of dataset is paramount. Unfortunately, many algorithms work like black boxes, and the results are hard to explain regardless of how good they are. Now, here is complexity. A complex model can find more interesting patterns in the dataset, but at the same time, it will be harder to maintain and explain. The maintaining and explaining such a complex model really hard. We also have data set size. The amount of training data available is one of the main factors you should consider when choosing the model. Neural networks is really good at processing and synthesizing tons of data. Features in datasets. The datasets that we have chosen before. So we're going to have some features where we shall be having column for the country, state, city, land average temperature, which contains global average land temperature in Celsius. We're also going to have land average temperature and salinity, land maximum temperature, which contains global average maximum land temperature in Celsius, land maximum temperature and salinity, land minimum temperature, which contains global average minimum temperature in Celsius also, land minimum temperature and salinity, land and ocean average temperature, which contains global average land and ocean temperature in Celsius. Lastly, land and ocean average temperature and salinity. Now, as we said, it's going to be Bayesian's theory. Now, Bayesian's theory is also known as Bayes' law, Bayes' rule, or Bayesian's reasoning, which determines the probability of an event with uncertain knowledge. So in probability theory, it relates conditional probability and marginal probabilities of two random events. When we have event A and V, the formula below is what we can use to get the probability in relation to the Bayesian's theory. Now, Bayesian's theory was named after the British mathematician called Thomas Bayes. We're also going to look at naive bias. The naive Bayes algorithms is a supervised learning algorithm which is based on the Bayes theory and used for solving classification problems. Now, why is it called naive Bayes? First of all, it's called naive. It is called naive because it assumes that the occurrence of a certain future is independent of the occurrence of other future. So there's kind of independency in the occurrence among futures. It is called bias because it depends on the principle of Bayes' theory. It is a probabilistic classifier, which means it predicts on the basis of the probability of an object. We have also some popular naive Bayes algorithms, which are spam filtrations, sentimental analysis, and classifying articles. Now, Bayesian networks, by definition, Bayesian networks are a type of probabilistic graphical model that uses the Bayesian inferences for probability computations. It represents a set of variables and its conditional probabilities that are directed acyclic graph. As being a network, we're having different variables or nodes connected together. So we're having A, B, C, D, can either be continuous or discrete in nature. In the above diagram, A, B, C, D are four random variables represented by nodes given in the network of the graph. Node V is its parent node and C is its child node. Node C is independent of node A. Now, what is the difference between Bayesian's theory and naive Bayes? The distinction between the Bayes theory and naive Bayes is that the naive Bayes assumes conditional independence, whereas Bayes theory does not. So the assumption made actually does not exist in the Bayesian theory. This means the relationship between all input features are independent. Let's look at difference between naive Bayes and Bayesian networks. Naive Bayes is a probabilistic classifier, which means it predicts on the basis of the probability of an object, while Bayesian network is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed acyclic graph. These are the references of my work. So you want to have a look, please check on the description link below. Thank you for listening. Please subscribe to my YouTube channel. Yo, have a good day.